Carpenter on Carpenter?
Yeah.
On Kubernetes, so all Kubernetes on AWS today. Just one remark, we will take some photos. If you have any problems with that, maybe approach me afterwards so we don't publish any photos on the meetup group with you on the picture. But besides, other than that, we will have two talks. First one is Vibo, we'll start with him, then we have a short break, grab some new drinks, maybe some quick discussions, and then we will go over to Alex, and then we have some final social time in the kitchen, eat the rest of the pizza, and then closing the night. So let's get started. Vibo, stage is yours.
Thank you. Hello everyone, good evening. My name is Weibo Zhao. I'm very happy to be here to give you a speech related to GitLab. The topic that I would like to talk today is empowering your DevOps workflow deploying a self-host GitLab instance on Kubernetes EKS with Terraform. But before my speech starts, I would like to ask you some questions. So first, if you heard about GitLab before, please raise your hand. Okay, since everyone heard about that. If you have used the GitLab in your project, please raise your hand. Okay, so thank you. So I also see some other people's did not raise their hands. And so for everyone, what kind of CI/CD tools are you use mainly in your team or project? GitLab and what else?
Jenkins.
Jenkins.
GitHub Actions.
GitHub Actions.
GitLab CI.
GitHub CI.
Perforce.
Huh?
Perforce.
Oh, okay.
AWS Code Pipeline.
Code Pipeline, yes. AWS native service.
Azure DevOps.
Azure DevOps. Cool. Anyone else? Okay, I think that's it. But most likely the GitLab is one of the widely spread tools that we can use. And there is a great advantage of GitLab instance is that we can build it by our own. So let's first talk about myself. My name is Weibo Zhao. I am a technical instructor, but I'm a freelance AWS technical instructor. And for the main job, I'm a DevOps engineer and also a Kubernetes instructor, and I'm a champion authorized AWS instructor. I lived in Karlsruhe city and not far from here, and I'm also a community builder, which also maintain a community of more than 60 people, but mostly online. And I like spending some time to make tutorial videos, play violins, and visit museums. And also, this is my LinkedIn address. If you can just search my name, Weibo Zhao, in LinkedIn, and you can find me. And also, these are several certifications that I have taken, and also my goal is to finish all the certifications in this year. Okay, so now let's talk about today's content that I have prepared for you. So at first I would like to give you some background about why I do the project of GitLab, and I will give you an introduction about the GitLab instance itself. And I will talk about the Terraform modules that I use to build up the GitLab instance, as well as the several Kubernetes components like the network policy. And I will also talk about some other sides of GitLab, like runners and backup, and also the gateways, takeaways. And so here I just prepare a photo, like every developers or DevOps engineers in our company says, CI/CD is really a good tool and it can really improve our working efficiency. But and then they ask the manager of the company, let's use this tool, and the manager says to them, okay, it's true. This GitLab is this CI/CD tool is really nice, but we do not want to pay for the license, and you need to build up on your own. And this build up this kind of CI/CD tool by ourselves is kind of difficult things that we have encountered. So this is the background information about in our team. I work as a DevOps engineer, and I need to provision the GitLab instance for the internal teams, because in our company we have multiple teams, and each team wants to have their own GitLab instances with their specific domain name. And as our teams are increasing, the number of our teams are always increasing, so I need to more or less provision like more than 20 GitLab instances for them. And so how to manage this kind of GitLab instance is a topic that I need to take concern. And first I come up with the idea that I use the GitLab Helm chart, which is a official Helm chart that GitLab provides for us, and I can use this Helm chart to deploy it in Kubernetes clusters. The idea is that first I create a toolbox container which stored in the container registry, and I launch this toolbox, and in this kind of toolbox I will provision all the codes. The code is mounted through a volume, and it is also backed up in the Git repository. And inside of this container, I use the Helm file, which is a file to deploy the Helm chart in Kubernetes clusters. And the Kubernetes clusters can be either deployed with Terraform or Puppet. This is the initial idea that I come up with, and then I start to provision these kind of things. And the first step I do it is through the on-premise virtual machines, but later I transfer to the cloud, and I will explain why I do this. So here is the GitLab architecture that I have provisioned in the on-premise virtual machines. And you can see that here the GitLab contains a lot of components, which is pretty complicated. No worries, I will explain about these kind of components later. I mainly use the GitLab, I use this rancher for Kubernetes clusters, and this GitLab instance are also used the LDAP, which is a lightweight directory access protocol for the data authentication, the Postgres database for the registry and the user information and metadata. Thank you. And also the monitoring systems with Prometheus, the S3 buckets for the backup, as well as the network file systems for the shared volumes. And this kind of architecture seems to be complicated, and my workflow is on this on-premise virtual machines is like this. So here is me, the DevOps engineer. So when I want to deploy a GitLab instance for our teams, what I need to do, I need to first execute a deployment script, which I write it through Bash, and this script will execute the code that I have provisioned in a local repository, and then it will run the Helm files to provision all the necessary Helm charts that are deployed in my Kubernetes clusters. And these local repositories are also backed in the GitLab, which is one of the which you can understand is like a GitHub, which is my source code. And later I get up a problem because I need to, because each GitLab instance are provisioned in one Kubernetes clusters, and for each team that internal teams in our company, I need to create a GitLab instance, and I need to create provision a Kubernetes clusters. And they are, then I get in trouble because I have like 20 of the teams, and many of them are, many times I need to change the same configurations in all of these repositories. And then usually the GitLab also have a frequent version release, so I need to change the same configurations through different repositories, and these changes are usually during the midnight, and I have trouble with changing all of these files. And so I come up with a refactor idea, and this refactor idea is not using the on-premise virtual machines, but using the cloud like the Amazon EKS. And this Kubernetes can actually locate it in any cloud provider like the EKS or Azure Kubernetes Service or GCP or any Kubernetes providers that you can use. And in this case, I do not provision one GitLab instance in a certain Kubernetes cluster, but multiple instances inside of one Kubernetes clusters. And in this case, I use the Terraform module to provision the whole GitLab instance. And when I change the config, I only need to change the config files in Terraform module, and without changing all the files like previous in all the local folders. Okay, now I would like to give you a short introduction about how this GitLab instance looks like. And you can see it is quite a complicated structure, but I will try to explain this step by step. So here I have drawn a square, which is my Kubernetes cluster that I provisioned through Terraform. And in this Kubernetes cluster, I defined the GitLab instance in different namespaces. And here you can see a namespace called the git minus team1 namespace. And in this namespace, I provision the whole GitLab instance in certain namespace with the official GitLab Helm chart. And for the other teams, I provisioned it in another namespaces, and so on. So there are also several other namespaces like the NGX for the ingress traffic, the Fluent bit for the logging and forward the log to the Elasticsearch, and Prometheus, which is used to collect the metrics and do the monitoring work. The search manager is for the Kubernetes certificate manager, and the MinIO is a fast storage service that has a high performance of storage. What else I provisioned is that I use the external services like the S3 bucket for the backup, and the Vault to store all the Kubernetes secrets, and the external PostgreSQL for the metadata and repositories, and also use LDAP login. And inside of each namespaces, there are also several deployments as well as stateful sets that I have provisioned. So let's talk a little bit about these components. So the GitLab shell, which is used to handle the SSH-based Git sessions, and the work services is actually the GitLab application web server with GUI, or you can understand it as a GitLab portal. The GitLab runner, which is also very important, it will run the GitLab jobs and send the results. The Gitly is a service to handle all the Git calls like git pull and git push. What else we have is CAS. CAS is a Kubernetes agent server which communicates with the cluster, and the GitLab exporter will export all the metrics that it gathers from the namespace and send it to Prometheus. And the sidekick is a Ruby background job processor, which will process all the GitLab job. And the PostgreSQL is storage for application metadata and also the user information. The registry is used to store the user's own Docker image. Like you can store your, when you build up a Docker image, you can store it itself in GitLab. And also the GitLab pages is used to publish static websites. The toolbox is used to execute periodic housekeeping tasks like backup. The last one is the Redis, which is used to store session data, temporary cache information, and also the background job queues. So these are several components that's inside of the GitLab Helm chart. What else we have is also several persistent volume claims, the secrets, the config map, as well as network policies. And these network policies, I will show you more details in the following slides. So now I can give you a whole workflow of this whole architecture of the GitLab instance. And now I will explain how we can use the Terraform to provision some architecture that's complicated like this. So the first idea that I want to share to you is the Terraform module. I would like to first ask a question. Have someone heard about the Terraform module previously? Okay, half of them. So thank you. And I would like to first explain the Terraform module, which is a container for multiple resources that are used together. You can use the modules to create lightweight abstractions so that you can describe your infrastructures in terms of its architecture rather than directly in terms of physical object. So this is the official definition of Terraform module, but I would like to explain it in a more understandable way. So if we create a Terraform project, so we will have a root module, and in here we will provision several Terraform files, which is has a abstractions of TV, and I use the main TF and to provision the providers and the Kubernetes clusters, and I use the Terraform modules, which actually looks like a template that you can define different sources. And inside of each modules, we can define the nested modules and provision the detailed resources that we want to provision. And also we can have other examples folders that will override or reference the modules that we have provisioned. In my case, the folder looks like this, and I have actually removed some unnecessary files and show you a simplified version. But the main idea looks like this. So the main TF and main vars TF is used for me to provision the Kubernetes clusters, and also the modules. Here I have 4 files, which is the GitLab Helm release file, which I provision the GitLab Helm chart, the network policies, the secrets that are specifically used for the Kubernetes, and also the variables of this Terraform modules. And then inside of these modules, I define several overrides, because Helm chart you need to use a customized value point YAML to override the default values. And all the configuration parameters that I have provisioned is stored in the GitLab YAML file. And then I have created several files like the git test.tf, which is my test environment, and dev environment, as well as a team environment. Like here, I just give you an example of git team 1, but if I want to provision for multiple teams, I can also just add a file here, git team 2, git team 3, and so on. So this is the structure of my project folder, and now let's deep dive into the code and to see how I created this model. So the first step that I have created is the namespaces for a certain team. So in this case, we can see that I have created a Terraform resource which has a local name of namespace git team 1. So this git team 1 is an example name of one of the team in my company. And I just use git team 1 as the name of my namespaces. And I have also add a specific labels for these resources, which is a key value pair. Project equals is a key, and the git is the value. And then, so with this kind of piece of code, I have created a namespace with a label project git. And then inside of these namespaces, I provisioned a model, and this model will use the source, the model files that I will show you in the following slides. And I also specify a variable name that I will use in the models, which is the team 1. Okay, so this is the namespace provisioning. And the next step is to show you what's inside of these models. The models are actually contains all the components that we can see here from this Helm chart. And I have provisioned a models GitLab Helm release Terraform file. And in here you can see that I use the official Helm release from the Terraform provider. And here I specify a variable which is a team short name. So in this case, I will use the team 1 as an example. And these variables will be replaced by the team 1. And here I also need to reference the URL of the official Helm chart of the GitLab, which is the chart gitlab.io, specifies the versions and also the chart name. And inside of the Helm release, I also need to, if I do not provide a value file, it will use the default parameters. So in order to customize it, I need to specify a values file, which will read the file from another folder, which is from the overrides gitlab.yaml. And inside of this YAML file, I specify all the customized parameters that I have provisioned for the GitLab instances. And here I also need to specify the variables that I need to use during the GitLab override files. Because, for example, here the GitLab YAML file, I just show a short piece of it. But actually, the configuration is really, really long, and you need to specify a lot of parameters. And here I just show you an example that how I provision a domain name for this for one of my internal team 1. The official Helm chart, I can give you an example. So if you search the GitLab Helm chart, and you will find this is the official folder of the GitLab Helm chart, and which I read it a lot. And you can see that inside the official Helm chart, there is a values.yaml file, and these are actually all the parameters that we can configure when we provision our own GitLab instances. And so this is our This is actually represented by this overrides GitLab YAML file. So what else do I provision? I also provision several secrets files. And the secrets files, as a developer, we know that the secrets contains a lot of sensitive information. And we are not allowed to store write these secrets hard-coded in our repository. So where could be a good way to store our secrets? And if you are familiar with AWS, usually we can use like the AWS Secrets Manager or the AWS System Manager parameter store. And another way that we can use for free is the Vault, from HashiCorp Vault. And inside of this Vault, we can store our key value pairs. And when we want to create the Kubernetes secrets, it will read the sensitive information from the vault, download the secrets, and then these secrets can be used by our different kinds of deployments or stateful sets. So here is an example of secrets that I have provisioned for the secrets. Here I use a vault provider from the Terraform, and then I need to specify a data using this Vault KV secrets version 2. And here I need to specify the mount path of that's where I store the secrets in the vault, and also the name of this secret. After defining the Git vault, I need to read, actually in the vault I store the secrets as a value pairs, key value pairs. And here I need to specify what kind of key that I have used in vault. Like here I provisioned a Kubernetes secret, which will use the secret information that reads from the vault key value pair. And the key is the S3 access key and S3 secret key. And so in this case, by provisioning this Kubernetes secrets, I can read the data from vault and then provide the S3 configurations as a Kubernetes secrets object. Okay. So after you successfully configure all the parameters, and then you can get access to the GitLab interface. And this interface is a something like that. Like what I showed here. So inside of this interface, you can create your own project, and you can test with an example pipeline to see whether your GitLab instance work or not. And a very important component in GitLab is the GitLab runner. As I have mentioned, it will run the jobs for us. And so the runners, you can only see it from the admin area. So you need to log in with your root account. And inside of the CI/CD, you can find the runners that I have provisioned in Kubernetes. And actually, if you see some tutorials of GitLab, and you can actually register a EC2 instance, the Elastic Compute Cloud from AWS, or even virtual machines as a GitLab runner. And here you can specify a registration token. And so if you find that your GitLab runner has a low performance, and you can provision a larger instance, like the EC2 instance, to make the performance better. And you can just register it with the registration token that's generated from here. Okay. So I have also mentioned that I have defined the network policy. So why I need to provision the network policy? It is because that I provision all the GitLab runners inside of one Kubernetes cluster. And this GitLab runner is very sensitive, and we need to make sure that the team member of one team cannot access to the GitLab runners of other teams. So this their team, the GitLab instance I provisioned for them must be fully separated. Must be fully separated, and so that no security issues happens between them. So how can I make sure that all the traffic is blocked? We can use the firewalls, but in Kubernetes we have another strategy, which is using the Kubernetes network policy. So here I just show you a graph. You can see that here is my Git team 1 namespace, and here is the Git team 2 namespace. And we do not allow any traffic between these two namespaces, but the Git team namespaces are allowed to communicate with other namespaces, and they are also allowed to communicate like the S3 buckets or some public services that I have provisioned. What else is that inside of one GitLab namespaces, all the GitLab components can communicate with each other, like the registry, the runner, the Redis, the PostgreSQL. They can inside of this Kubernetes namespace, they can communicate with each other. So so I define a network policy with Terraform, which use the Kubernetes network policy, and its name is allows the intra Git namespace Git namespace traffic. So inside of this namespace, all the traffics are allowed to communicate with different pods. And how I define it? I specify the ingress and egress policy as a type, and the network policy has a specific feature that if we define the policy, what we have written is allowed. What we do not written is blocked. And so based on this kind of feature, I write that inside of these namespaces, all the pods, which I selected by the pod selector with a bracket. The bracket means that I select all the pods inside of these namespaces, and then they can communicate within each other. So that's the basic what that means from this block, which means that I repeat again, which means that inside of this namespace, all the pods can communicate with each other, so that the GitLab instance can work. So another network policy is that we need to allow the traffic that each Git namespace can communicate with other namespaces. And here is where the label works. Like for each namespaces, I provision a label called the project Git. And so inside of these namespaces, I define it like this. For all the pods that I have selected, it can allow the ingress traffic from the namespaces, which the key is equals to project, but the values are not equals to Git. So why is not in? Not in means that it allows all the traffic from the namespace without this name, without this key value pair. And as all of my Git team namespace has this certain label, so all of them cannot communicate with each other. But the other namespaces which do not have this label can communicate with Git team namespace. And so with this network policy, we fully separate all the namespaces. And yeah, so this is how these two network policies works, and to make sure that all different team members from different teams, they cannot access to the others' work, to prevent these kind of security issues. And what else that might be also important for the GitLab instance is the backup. So imagine I have provisioned a GitLab instance for you, and you have put all your code inside of this GitLab instance. And sometimes the instance has some problem and it has a downtime, and you cannot get access to your GitLab. And even worse, all the data is lost. And this is actually unacceptable in the production environment. So the backup and restore is really, really important for us to make sure all the data is safe. So how can we do? How can I do it? So we use the external PostgreSQL database, which you can also use like the RDS or RDS for PostgreSQL or Aurora for PostgreSQL, and then you can the GitLab has a component called the toolbox. The toolbox is as I have mentioned previously, it's used to do the housekeeping work. And here it will create a snapshot for the external database, and then send the snapshots to the S3 buckets that can be used for the backup. And for the restore process, the toolbox will download the previous backups from S3 buckets and then restore it to the new provisioned PostgreSQL databases. And so this is how the backup and restore work. We can do it automatically, and we can also do it manually. And in the right side, I show you a configuration that we can do it automatically. Like here, I need to specify the backup parameters. I use the object storage, which is the S3 bucket. And here, these secrets, I specify the access key and secrets key informations of my S3 of the Kubernetes secrets. And here, what's important is here, I define a cron job. The cron job is enabled and it is scheduled like this. So if you have maybe you have learned about the Linux previously. This 0, 1, star, star, star as asterisk means that it will execute this job 1 time per day. And also I specify the extra args, like the maximum backup is 7, which means that I will, every day I will take a snapshot of the external database and store it in S3 bucket. And this snapshot will be stored for 7 days. So if you lose if you want to revert to a previous registry version, and I can make sure that I can revert your work to the one week before. And also we can do it manually by writing the kubectl command. And first you need to find out the toolbox toolbox pod inside of the Git. Sorry, here I not the GitLab, but the Git team 1, the certain namespaces. And then you need to get inside of this toolbox and give it several args like backup utility. And for the maximum backup 7, which will do the same work as what I showed here. And if you want to restore, you can specify the restore and -t. This t is the tar file, which means that the snapshots that we store in S3 bucket is actually a tar file, a zipped, a compressed file that we store in S3, and you can specify the name of this S3 and then to restore back to your external database. So this is how we do. I show you what we done for the this is in the Grafana, and here you can see that I store the 3 backup, and then you can see that the backup size will increase every day. What else is that not only backup for the database, we also sometimes need to back up the artifacts that's generated from our GitLab instances. And every time when the runner launches a job, and this job will so every time when we trigger a pipeline, actually the runner will launch a job. This job will manage a pod, and this pod will actually push the data. So I can give you an example here. So this is an example GitLab instance that I have provisioned by myself. And here, when I have just show you just a very simple example that with a GitLab CI file. And here I have specified a image, two stages. One stage is called Hello World. The other is show operation systems. And it's used the Hello World will use a image, and it will generate a operation system file, and this file will be uploaded as a GitLab artifact. And then the other stage is just reads the artifacts and print out all the information. So this is a very easy pipeline, and when we actually execute, so actually when we, for example, run this pipeline, and it will you will see that so it will take a little bit for the run, but we can first, let's save some time. I can go into a job that I have previously launched, and you can see that here from the logs you will see that it will specify it's running with GitLab runner, and it will provision the environment, execute all the commands, and later you will see uploading the artifacts for the successful job. And these artifacts are actually uploaded in my S3 bucket. And sometimes you will also find that if you have a large environment and the artifact file is takes too much time to configure, and in this case you can use the cache. The cache, which will means that the artifacts will be stored in the GitLab instance for a while. And next time when you run a pipeline, you can use the cache file from a previous pipeline. And these caches are stored in min.io, which is a high performance object storage inside of my GitLab instance. So after you provision the GitLab instance, you can then hand over to your internal teams, and you can also assign them as an administrator. And here, sorry, I have just stitched out the names, but actually you can, if you log in with the root user, you can assign one of the developers or team managers as an administrator, and they can create their own GitLab groups, and they will add all the team members inside of that group, and so that they can work on this the GitLab instances that we created for them. Okay. So so that is the project I have worked on for my company, and some takeaways that I want to bring to you is, the first is that the Kubernetes namespace can be a good place to separate hosting applications with the help of network policies. So if you have some security issues that, like the different instances cannot communicate with each other, it is actually not necessary to provision it in different virtual machines or totally different Kubernetes clusters. You can still provision them in a same Kubernetes cluster, but use the network policy to separate the traffic. The second takeaway is that the Terraform modules can greatly save your time if you have repeated configurations. So if you still remember my Terraform module structure, so every time if I want to provision a new team in my for my company, then I can specify the team name and create a namespace and reference the modules, and then run the whole push the code to GitLab and run the whole pipeline, and then we will have a GitLab instance that's provisioned for the new team. And this is much more efficient compared to different local repositories. The third takeaway is that there is a very nice tutorial that I recommend all of you to do when you have time, which is called the GitLab for EKS workshop. And as the Kubernetes can be provisioned by multiple cloud providers, so the topics that I have explained to you can not only use in EKS, but also for Kubernetes from other cloud providers. And if you like, you can just search the GitLab for EKS workshop, and then the first link will be this tutorial. Okay, so that's mainly about all about my presentations. Any questions so far? Yeah, please.
Yeah, maybe one. The network policy you showed before, so like GitLab namespace can communicate with different namespaces, but not with our GitLab namespaces. How? Yes.
This one.
How can you resolve use case with an architecture like this if a team in a Git team 1, for example, provide like Docker images, and the Git team 2 depends on these Docker images, but they have to work like separately in parallel.
Ah, okay, I understand the use cases. Okay, so let me go back from the architecture. Maybe it's easier to understand.
Mm-hmm.
So here I just I do not show actually all the components. So if you use like the image that we use in our team, is stored externally from the Kubernetes. We are using the Harbor as a external image solution, and actually every Git team namespaces, the traffic can communicate with outside container registry. So that in this case, if you define this image as public, then every team members from different teams can use the same image.
Okay.
So in summary, the registry are not stored inside of the namespace, but outside of Kubernetes cluster, or not Kubernetes, or outside of this namespace. It can also be other namespaces. Like if you provision like Docker Hub, it's definitely outside. But if you provision a Harbor, you can create a separate Harbor namespaces, and then the traffic is then allowed.
Okay, but will you be able to trigger like, I don't know, a kind of quality gates in team 1 through the changes in team 2? Or the other way around? I mean, like, if we say like team 1 is responsible for the images, so for images the team 2 depends on. Is it possible for team 2 to know that team 1 released new images and they have to rebuild their products and check?
Ah, okay, yeah. It is possible. I think it's in our case it's through the Harbor. I mean, for example, if this image that you build is not for your own team, but for the enterprise wide images, and you can create a Harbor namespaces here. And in Harbor, you can also specify a event, like every time when the stable images are pushed in the Harbor, it will send the notifications to all the developers that please use this image now. In this case, you can notify the other teams.
Mm. Okay. Okay. And if we use things, so we talking the same, but not about the Docker images or about other artifacts. Will it be possible without Java, for example?
Artifacts will be a little bit. I think we didn't do with the artifacts because usually the artifacts are generated from each pipeline, and the pipeline, the pipeline artifacts will be uploaded to the S3 bucket, and we will provision one S3 bucket for each team, so that the S3 bucket is also separated. But if you like, you can also specify the S3 bucket. For example, in AWS, it has the event notification, and then it can, when the artifact is uploading in S3 bucket, it can trigger an event notification, and then you can send this event, like launch the SNS or with Lambda to notify all the team members that you want to notify.
Okay. So if Team 1 release a new library, Team 2 can get notified?
Yes, it is technically possible. But actually we didn't do that often. Images might be a good point, artifact not.
Okay.
Yeah. Any other questions? Oh. I think sir, please.
So if this is a real world example, why would you deploy a whole dedicated GitLab instance per team instead of just having one GitLab instance for all teams?
Yes.
And second question is, why would this be cheaper than just paying for a GitLab.com license for every user?
Let me first answer your first questions. So, we have multiple teams, and each team has the administrators, and we want to have agile methodology that we maintain the team in a small size. That one administrator can freely add the new developers or remove a developers, depends on the. If we put all the projects inside of a whole GitLab instance, it will be a little bit hard to manage because we have different projects, and that means that all the teams can see the codes from each other. And imagine if you have a very large company, all the codes stored in the same place, when one employee can read all the codes, and it is not suitable for the compliance.
If you have so much code out there, it would be the best that everybody has access to it, actually.
Yes, that's the truth.
If you have some code that shouldn't be visible, then there's another question, why is this in Git at all? I mean, secrets and credentials shouldn't be stored in GitLab at all. But you can have top-level groups, each one per team, and then you can make even them private, and then one GitLab instance would be also fine.
Yes, that would be possible. Would also be possible, but as I said, it is mainly because of the company obligations. It's they are from design this kind of architecture like this. And this is actually the requirements I have received, and so
if you create private groups, make all of them private, and have one group owner for each of these groups. They don't see each other anyway.
Yes.
That's company's regulation. It demands compartmentalization on the host level. That's based on the regulation of which sector you work, which company you work, and which regulation your companies. If you have so companies that have advice to companies that are concurrents, they shouldn't host the code in the same.
But usually you don't have this circumstance within the same company, isn't it?
can have a consultant have a give consultant to advertising company.
Outsourcing.
Yeah.
Yes. In some company you can visit room for all the team.
What else is that? There also in AWS there is a concept of reducing your risk radius or the blast radius, which means that if I control all my GitLab instance in a certain namespace, then I can if I can delete this namespace, then to only affect one team. If I do it in a whole GitLab instance, and if I for the maintainer, if I do something wrong, it will affect all the developers inside of my company, and it is a huge risk that I need to consider.
It's also sort of like redundancy.
Yes, this reduce the risk. The second question, please.
Payment.
Your second question?
Sorry, he's asking for the second question. So would it be cheaper than paying for the licenses on a managed GitLab instance? Talking about the total cost of ownership for all of the infrastructure you're showing and maintaining that. How many? And your development
You can, actually, it really depends. Yeah. So we have an internal contract that our company has already provisioned all the have our own data centers. So when we create the Kubernetes clusters, it is actually fixed cost. That's why if we use it or not use it, it costs the same. But actually, if you do it in AWS, for example, provision in EKS, I haven't actually tried it, but you can see that it is much cheaper when you provision one Kubernetes EKS cluster to provision all the instances, and in compared to that you create multiple Kubernetes clusters for each team.
The question was doing it yourself versus buying the license from GitLab.
From the GitLab. Yes,
So
exactly.
you wouldn't need the time to engineer your stuff, you wouldn't need the time to maintain your stuff, you wouldn't need the time to make that setup. That's the question.
It's rather a business
Good point. I actually didn't compare really because this is from my background already not allowed.
I think there might be risk if GitLab
manages. I would like to see the best thing is that to just contact the business marketing departure from GitLab, and they will have the exact price model for each team. And I think they are for large enterprise. They will have also some discount if you have cooperation.
Yeah, there are multiple reasons for why companies would use GitLab.com or host them themselves. One could be compliance. The other would be they just don't want to be vendor logged in with GitLab.com in case of any pricing updates, for example. So
yes.
It's all fine, but the question is that it should be for free and not cost anything, so that costs also anything.
So if you want to, actually I have a good reference. So
Of course there are many reasons, but I think the question is why is it cheaper?
yes. So actually you can see from the GitLab release, so every time when it release a new GitLab versions, it will have figured out which one features are available in the for the paid versions, and which one is only for self-hosted. So which means that the self-hosted itself is also satisfies the compliance. And also, if you provision the self-hosted GitLab instance, it can also make sure that our data is fully located on our own data centers. It will not transfer to the servers from GitLab company. And this is for some company compliance or regulation requirements also a very important aspect to consider.
These are completely valid reasons. I think he was just wondering because you said it's cheaper in the beginning. You said it shouldn't cost anything. That's why you
not cost anything. We still need to pay for the Kubernetes clusters and instance, the storage that we are using, and databases. Yes, please.
Yeah, I'd like to ask about costs. So customer some time ago evaluated options to go from Bitbucket to either GitHub or GitLab, and GitLab was something about 100 per user, while GitHub Enterprise costs about $20 per user. So you can
Oh,
Different
okay.
features.
Yeah, there are different features. Yeah, good point. And now, and also they are developing ways. Like our company's developers are already familiar with GitLab CI files, and sometimes it's also you need to also consider some aspects of the knowledge level of your team, and to choose the suitable CI/CD tools. Yes, please.
Question to what you showed there. How do you roll updates then now? Or what's your update process now?
Ah, okay.
for deploying
Yeah, that's-
new versions.
Yes, that's a very nice question. So previously it's pretty horrible, which means that every time when I want to update the GitLab versions, I need to change first in the local code repo and push it into remote and then execute it and so on. So I need to change all the local repositories here. But now, after I do this refactor, I just need to change the time release files that are stored in the Terraform module that I have showed you here. Here, this version.
Do you expose the version as a variable there as well, or is it one version?
It can. Currently, I didn't specify it as a variable, but
So
actually
you
we can
I
change it.
understand. So,
Yeah.
so in case of an update, you still have to update the entirety of all your instances, basically. So there's no way to test it on a single instance first and then do a big update later on. You would
Yes,
just go and
actually,
update all.
actually, this is a really good question. Actually, what we are currently building is here. So, but I actually didn't finish it first. So there is also a git dev and git test. So usually we will test all the. We will actually separate this infrastructure and to make sure that the git dev and git test, these two Terraform files, can be first provisioned with the new versions. And if in these two environments that it works well, then we will then roll out the other changes from the Git team 1 and Git team 2 team. As I have mentioned, this is already a fully simplified version, but actually we are always testing with the dev and test first. And when the new version is fully okay and we have fully tested, and then we will trigger to the customer for our internal teams in production environment. Okay. Thanks a lot for your attention.
One more question maybe,
Yeah,
and then
one
maybe
more.
short break.
What's used for cluster autoscaling?
Huh?
What is used for cluster autoscaling? Or you
The
run limited to fixed amount of
yeah. So here I have provisioned the two node pools with 20 work nodes in each work pools, and these two work pools are are used as a fill over. Like one node pool has some problem, it can fill over to other node pool. And if we want to scale for the new larger Kubernetes clusters, we need to provision new nodes inside of the Kubernetes clusters, which I will define in the main point TF files, and so that you can add more instances inside of the existing Kubernetes cluster.
In other words, there is no autoscaling, right?
It is not auto
Not the auto scaling. It is it is a manual scaling work. Currently, we have. So usually we are not allowed to scale in, because that's our teams inside of company doesn't have a very huge change of the push code, and so usually we see that the usage is always increasing. So we just need to add more nodes. That's enough. And this project is also fully internal for the internal customers. It's not for the outside, so that we do not have this kind of traffic problem. Okay. Thanks a lot for your attention.
Thank you. Take a 10-minute break and then be back. Grab the drinks.
Habt ihr heute tagsüber getan?
Ja, voll.